Hey everyone, my name's Courtney and I'm here with Alana and Abby, and today we're going to be talking about our experiment called a better chocolate chip cookie. So here's a quick overview of this presentation. We'll be talking about our project overview, research questions, our original hypothesis, the underlying data sets, methods used for analysis and demonstration, our insights and conclusions, and finally our refined hypothesis. So first, here are some of our research questions. We're going to be asking if the fat and sugar substitutes have a significant effect on the taste and texture of the cookie, what ingredient combinations consistently will get the highest ratings, and what ingredient combinations are the healthiest, looking at calories, fats, and carbs. Our original hypothesis, or our null hypothesis, is that there is no difference in taste when substituting the sugar and fat in a chocolate chip cookie. Our alternative hypothesis is that there is a difference in taste when substituting the sugar and fat in a chocolate chip cookie. However, realistically, our expectations are that there will be a difference based on the ingredients that you put into the cookie. For our underlying data sets, we made 9 batches of 10 cookies, so that means we had 90 test subjects because each test subject was only allowed to try one cookie. Here are all the different combinations of ingredients that we used. So there was butters, applesauce, and white beans as the fat, and the sugar was either normal sugar, Truvia, or Splenda, and we did every variation of these fats and sugars. And then we made a survey for the people who were eating the cookies to fill out. They looked at the texture rating. They did it on a scale of 1 to 5, so 1 being like the worst chocolate chip cookie that they've ever had, 3 being average, and 5 being best, and they did the same thing for the taste. And then we also asked them to describe the texture, whether it was chewy, cakey, or crunchy, to see if maybe that would factor into our results at all. So one of the first methods used for analysis in JUMP was distributions. Here are showing all the distributions for Splenda. You have Splenda with applesauce, Splenda with butter, and Splenda with white beans. We felt that it was important to capture the mode for all of these, so you can see that the taste and texture for every variation of Splenda with fats received 4s most of the times as its rating, except for the Splenda with applesauce, which received 3 most of the time for texture. This is the distributions for normal sugar now. We have applesauce, butter, and white beans. The highest rated one was the sugar and applesauce. Most of the ratings were 5 for these categories, or these combinations. Surprisingly, sugar and butter, the texture received a lot of 3s, and the sugar and white beans, while it got good ratings on texture, it didn't receive so well of ratings for taste. So finally, for distributions, we have the Truvia category, applesauce, then with butter, and then with white beans. It seemed to receive 4 mostly across the boards for taste and texture. However, the texture for the Truvia applesauce combination did receive a 3.
So now we're going to be looking at a chi-square distribution. This picture here is showing a mosaic plot of the sugar versus the texture. The 3 different textures we were asking people about were if the cookie was cakey, chewy, or crunchy. And again, the 3 different sugars were Truvia, Splenda, and normal white sugar. So for the Truvia, we can see that more people rated it as cakey, and the same thing for Splenda, but for sugar, more people said that it was chewy. Now looking at this contingency table for the mosaic plot, we can see the actual values that are here. So 16 people rated the Truvia cookies as being more cakey. And same with Splenda, 20 people rated it as cakey, and 18 right here rated it as chewy. So now looking at the p-value, we can see that it is less than 0.05, meaning that it is significant. For a chi-square distribution, we know that the null hypothesis is that the 2 things you're comparing are independent of one another. But this p-value here is showing that they aren't independent of one another. So the texture does rely on the type of sugar that you're using. So now looking at another mosaic plot of this one is actually butter versus texture. So the types of butter, again, we're using white bean, applesauce, or normal butter. We can see here that white bean was rated as more cakey, and for the applesauce, we can't really tell which one is more or less for chewy and cakey. So we'll have to look at the contingency plot for that. And for butter, we can say that more is in the chewy area. Okay, so looking at applesauce, we can see that cakey and chewy are equal. So now looking at the p-values, we can see that they are very much above 0.05. So we cannot reject the null hypothesis, which is that they are independent of one another. So we can say that texture and the butter type don't really correlate. So now going into ANOVA, we can look at the butter versus the taste and the sugar versus the taste. So with an ANOVA test, the null hypothesis for this would be different than in chi-squared. It would be that there is no difference between the two things that you're comparing. So right here with the butter, we can see the p-value, which is very much way above 0.05, and meaning that we cannot reject the null hypothesis. So we can state that there is no difference between the butter and the taste. So then going over here to taste by sugar, this p-value is below 0.05. So there is a difference between the type of sugar that you're using and the taste that's going to be a result. You can also look at these graphs that they give you. So right here you can see that the different means of each of these are very close to the mean, the overall mean of taste, which is at 4. And right here for the sugar one, you can see that there's quite a lot of variance between these three different categories, the Trivia, Splenda, and normal sugar. So now looking at the butter versus texture and the sugar versus texture. The p-value for the butter versus the texture is quite high, and we cannot reject the null hypothesis, so there again is no difference between the texture of the cookie and the type of butter that you use. And right here with the sugar, this one's a little bit more difficult to quantify because it's kind of close to 0.05. So this would require more analysis in determining if the sugar actually has an effect on the texture of the cookie.
We ran the model script that the DOE created. After running the least squares model, we ran the prediction profiler and we found the maximum desirability. From these results, you can see that the preferred butter substitute is the white bean puree, and the preferred sugar substitute is not even a substitute, but the normal white sugar. Looking at the desirability on the left-hand side, you can see that it is not 100% desirable, but it is 88%. Our last test and jump included a linear regression to see if there was a correlation between texture and taste. The R-square value for the line is 0.19, so the graph is not a great representation between the relationship of taste and texture. But looking at the ANOVA and the F statistic, you can see that it is 0.001 and that it is significant. But this just means that there is a significant difference between each texture, which makes sense. So the conclusion from looking at this test is that there is no correlation between taste and texture, but we feel that further testing is required. The results for the study contain many variables, such as people having different taste and texture preferences, which may alter their rating. The ingredients used when baking also affect how the cookie bakes, but to remain consistent, we bake the cookies at the same temperature in the same oven for the same amount of time. Also, we noticed while conducting the study, some people may not have been honest with their ratings because they did not want to hurt our feelings. This is not necessarily true, only a speculation. The table on the slide displays the calculated number of calories, fat, and carbs just based on the ingredients we are changing in the cookies, so you can see how the different ingredients affects the nutrition in the cookie. In terms of calories as well as fat, the applesauce and Truvia, applesauce and Splenda, white beans and Truvia, and white beans and Splenda cookies are the healthiest options. In terms of carbs, the healthiest option is butter and Splenda. However, when it came to taste and texture, people preferred the applesauce and normal sugar cookies the most, seeing as the mode, the number that shows up the most, for both categories is a 5, the highest rating possible. But when it came to maximum desirability, the prediction profiler suggested that the white beans and normal sugar cookies were the best cookies that would produce the maximum desirability. We are not sure where this discrepancy comes from, but this is something that we should look into for further research. Our null hypothesis of there is no difference in taste when substituting the sugar and fat in a chocolate chip cookie is half true, half false. As shown in the previous test results, the sugar used does have an effect on the taste of the cookie, while the butter used had little to no effect on the taste of the cookie. If we were to conduct this experiment again, we would focus more on the sugar aspect of the cookie, and maybe even see if there is a causation between the texture of the cookie and the taste rating it is given. There is research out there that proposes that we like foods based on the texture rather than the taste of it. So if we were to do this again, we would focus on that aspect in relation to the sugar used in the cookie, because as shown before, the sugar does have an effect on the taste as well as the texture of the cookie. Thank you for watching our video.